Hello and welcome to yet another video of Cornerstones of Math. In this video, I will solve the following problem from this year's South Korean College Scholastic Ability Test, the test for high school seniors who want to start their college in year 2026. So we have a lengthy problem right here, and the thing is, you may have already guessed from the thumbnail, but this is the problem about graphs of the functions. Therefore, I will draw the graphs for you while I'm reading the problem. So the problem says in the first quadrant, there exists point A, B on the curve y equals log base 16 of 8x plus 2. So like this. And point B on the curve y equals 4 to the power of x minus 1 minus 1 half. So point B exists like this. Moving on. The reflection of point A across the line y equals x lies on line OB, where O is the origin. So this is the reflection of A across line y equals x, which I will call A prime. So this point A prime lies on the straight line OB. Next, the coordinates of the midpoint of line segment AB are 77 over 8, 133 over 8. So this is the midpoint of line segment AB. Hence, the coordinates of this point right here is 77 over 8, 133 over 8. And A times B is equal to Q over P, where P and Q are co-prime natural numbers. Find the value of P plus Q. This is essentially the same question as find the coordinates of point A, B, because P and Q are obtained from coordinates A and B. Alright, so our approach here is pretty obvious. We need to set up the equations using conditions given in the problem, which are also indicated on the graph in the figure. Let's start with point A. Point A is on the curve y equals log base 16 of 8x plus 2. Hence, B is equal to log base 16 of 8a plus 2, which can be considered our first equation. Next, I want to move on to the reflection of point A across line y equals x, which we call A prime. Reflecting a point across the line y equals x is easy. You just switch x-coordinate and y-coordinate to obtain a reflected point. Therefore, the coordinates of point A prime is B, A. Then we have point B. If you want, you can introduce two additional unknown variables for its x-coordinate and y-coordinate, but what I prefer to use is that point A prime is on the line OB right away. Based on this given information, we can write the coordinates of point B as KB, KA, introducing only one additional variable, K. And then we use the fact that point B is on the exponential function graph, which gives Ka equals 4 to the power of KB minus 1 minus 1 half, which is our second equation. Finally, we use the midpoint condition. The midpoint of line segment AB is 77 over 8, 133 over 8. We use the coordinates A, B for point A and KB, KA for point B. So from x-coordinate and y-coordinate, we can obtain two equations, A plus KB over 2 equals 77 over 8, and B plus KA over 2 equals 133 over 8. Now, if you take a look at the equations that we obtained, you'll realize that we obtained 4 equations, while we only have 3 unknowns, A, B, and K. So this problem actually gave you an excess condition, which resulted in having more equations than unknowns. But that doesn't mean that this problem is easy. The biggest problem is you'll soon notice that it is impossible to solve this system of equations by so-called standard methods, such as adding or subtracting the equations, or substituting one equation into another to reduce the number of unknowns. This means that we have to rely on some non-standard methods, such as judicious manipulation of given equations, clever algebraical or even graphical insights, which allow us to make intuitive guessing of the roots, or whatever you like to call them. Such unique thinking skills can be developed by a lot of experience. Here I will show you what I think is the simplest method. First, let us observe our first two equations. In the first equation, b is given as some log value of a, and in the second equation, a is given as some exponential value of b. So maybe these two equations are of the same form. Based on this intuition, let us solve for a in the first equation and express it in terms of b. So from equation 1, removing the logarithm gives 16 to the power of b equals 8a plus 2. So 8a equals, let's write 16 to the power of b as 2 to the power of 4b. So 2 to the power of 4b minus 2. And if we divide by 8, we obtain a equals, dividing by 8 gives 2 to the power of 4b minus 3, then minus 1/4. Meanwhile, some of you may have realized that this solving a for b is the same process as obtaining the inverse of a function. That is, the inverse of the given logarithmic function is y equals 2 to the power of 4x minus 3 minus 1 over 4. In order to compare this to equation 2, let us change the base into 2, which gives ka equals 2 to the power of 2kb minus 2 minus 1/2. We have minus 1/2 in the constant term and minus 2 in the exponent, while in the first equation, we have minus 1 over 4 in the constant term and minus 3 in the exponent. Therefore, if we multiply this by 2, then the first equation can be written in the same form as the second equation, with minus 1/2 in the constant term and minus 2 in the exponent. If we compare these two equations, you can easily realize that substituting k equals 2 in the second equation gives the exact same relation as the first equation. And if you think about the meaning of k in a graphical sense, there has to be only single value of k, so we can indeed conclude that the value of k is 2. A quick side note here, where I will provide another intuition to approach this problem, this time in a more graphical sense. This process is a bit more complicated than the previous method, but also more interesting in my opinion. So we have the inverse of the logarithmic function, y equals 2 to the power of 4x minus 3 minus 1/4, and we have the blue exponential function, which can be written as y equals 2 to the power of 2x minus 2 minus 1/2 for easy comparison. The key question here is, what is the relation between these two graphs that can be inferred from their equations? Well, it is not easy to find out, to be fair, but somebody can guess that this is actually a special kind of linear transformation called scaling by a factor of k. That is, moving every point x, y on the graph to a new position kx, ky. Consider we have an initial graph, the red one in this figure, and we denote the point on the initial graph as x, y. Then by moving every x, y to point kx, ky, which I will denote as x prime, y prime, we obtain a new graph, a scaled graph, the blue one. Obtaining the equation of a new graph is easy. X, y can be expressed as x prime over k, y prime over k. So if we insert this expression into the equation of the initial graph, the relation between x and y, we can obtain the equation of a new graph, the relation between x prime and y prime. That is, if the equation of the initial graph is f of x, y equals 0, then the equation of the new graph can be obtained by replacing x and y with x over k and y over k. With this knowledge, if we take a look at the equation of the inverse and the equation of the blue exponential function again, you can notice that if we replace x and y with x over 2 and y over 2 in the inverse function, then we obtain the blue exponential function. This confirms our guess that the blue exponential function is the inverse of the logarithmic function scaled, or in this case enlarged, by a factor of 2. And our definition of k means that our k is exactly the value of the scaling factor, hence we know that k is equal to 2. So this was another interesting method to find k, and with the value of k determined, the rest is easy. K equals 2 changes either the first or the second equation into 2a equals 4 to the power of 2b minus 1 minus 1/2. And then we have third and fourth equations, now containing a plus 2b and b plus 2a. And this is just a simple linear system, so we can easily solve this system of equations to obtain a equals 63 over 4 and b equals 7 over 4. We need to check whether these values satisfy the other remaining equation, and they indeed do, hence these are valid solutions. The problem wants us to calculate p plus q, which can be obtained by first calculating a times b. So if we calculate a times b, we obtain 441 divided by 16. Hence, the value of p plus q is 457. And that's all for today's video. If you enjoyed this video, then please go check my other videos as well, and please hit the like button for a good measure. Thank you for watching, and I will see you in another video.